Hello, my name is Benjamin Sellinger. This is for exam number 2, midterm number 2. I can't really flip my camera around, but this is me. Hello. I have 7 minutes left on my test, so just in case, this will be emailed to you. But let's start first off with what I did. So first, we're trying to find the current through each branch of the circuit. So that would be this branch right here, this branch right here, and this branch right here. So corresponding to those currents would be current 1, current 2, and current 3. And so I have my current for, because this voltage is greater than this voltage for each battery, so I'm just going to assume, it doesn't really matter though, but the current is going to be going this way for this loop, and then this way for that loop. And so because these two resistors are in series, I'm going to be combining them just to make my life a little bit easier into what I have here, which is R2 and 4. And so once I have my R2 and 4 right here, which is 1,400 ohms, I will be using Kirchhoff's rules to calculate each of the currents through each branch. And so I have here these little A, B, C, D, E points, and so those corresponds, like you see, to on my little chart there. And so first I'm going to be using my junction rule. So I'm just going to say we're going to go for the point C, and we don't have to do both junctions. We only have to use one junction because, well, that's what it says, but also because if you use both junctions, then it's going to be the same equation, so it doesn't really matter. So for solving that right here, because the direction of our currents, the current going in is equal to current going out, so I have I1 is equal to I2 plus I3, and that's going to be our first equation. And then I'm going to be using the loop rules to calculate, because we need two other equations because we have three unknowns, I1, I2, and I3. So for our second equation, I'm going to be using this loop, which is going to go to A, B, C, F to A. So we'll go A, B, C, F, and then back to A. And so when we do that, our current is going to be starting off at A, and then it's because going in the direction from negative to positive here, it's going to be a positive voltage to our delta V, which is going to be, because of the loop rule, delta V is always equal to 0. But so we're going in the right direction, so it's going to be adding the voltage to the battery, and the current is going to keep on going along, and then through the loop we're going to hit this resistor right here, which, because the current is going in that direction, it's going to be a negative, so the voltage reduction from that resistor, which I equals VR. And then because we're going to be going in the opposite direction of this battery, we're going to be minusing that voltage. And then back here through, it's going to be minusing the voltage reduction of that resistor. And that's our I1, our equation 2. And then similarly for equation 3, we're going to be going from C to F and then back to C. So we're going to be starting here, and then we're going to go C, D, E, F, and then back to C. And so similarly like before, it's going to be, but because we added these two resistors together, it's going to be subtracting that that voltage reduction from the resistance of both of those resistors, R3, 4, and then back through here. And then because we're going against our assumed current, we're going to be adding that voltage into our system, so it's going to be plus 17 volts. And then because we hit this resistor, but because the current is flowing in the opposite direction, instead of normally minusing the voltage reduction, we're going to be adding that voltage reduction. And so then we're going to have three equations, three unknowns. We're going to solve them right here. That's our equation, getting short on time. And then for our last kind of parts of the question, we're asked to find the power of each consuming component. So for this, I'm going to be using the equation power is equal to our current times our resistance. And so I'm going to go through each resistor, but because they're in series, our 3/4 is equal to R1 plus R2, but because in series, our current through each resistor is going to be the same. It's going to be the same. I know I'm a bit over time. And then for this one, I'm going to be using P equals, or power is equal to voltage times current. And then just solving using all of that stuff. It's all very well explained. That's that. And then thank you for listening. I know I'm a bit over time. 2 minutes left. Hopefully you'll see it. It'll be on YouTube. Bye-bye.